Hello, today we're going to start talking about basic statistics and some of the vocabulary associated with that. First, your main statistical vocabulary would be mean, median, and mode. So you may have heard of each one of these throughout your years of mathematics. So the mean is your average, which is the sum of all numbers divided by the total number of numbers. Your median is simply stated the middle number. And so this is easy if you have an odd number of numbers, like 5. So let's just do 1, 2, 3, 4, and 5. My middle number, I think of it like a teeter-totter, 2 and 2 on each side, so my middle number is 3. The problem really arises when you have an even number of numbers. So like you could say 2, 3, 4, 5, 6, 7. And so if I were to keep this even, I would notice that I could have 3 on one side and 3 on the other, but what's the exact middle number? And so what they do is they average the two. So what I have to do is kind of think of this again as a teeter-totter, and I'm going to average the 4 plus the 5 and divide by 2, which is 9 divided by 2. And if we're putting it in decimal form, that's 4 and 5/10. And so my median in this case would be 4 and 5/10. Okay, so that's something that you have to keep track of when you're dealing with median. It's very important. And then the mode is the most frequent number. And this becomes pretty easy if you had, like, say 1, 2, 3, 3, 4, 5. You would be able to see that your most frequent number is this pair of 3s. Where it becomes difficult is when you really don't have a clear indicator. So what I mean by that is, like, if I had 1, 1, 2, 3, 3, 4, and 5. In this scenario, I'd have 2 most frequent numbers. And so my mode would be 3 for that first one. My mode would be the set of 1 and 3 for the second one. And you can kind of expand that. And so you can, like, say, well, what happens if I had a 1, a 1, a 2, a 2, a 3, a 3, a 4, a 4, and a 5, and a 5? Well, this, in fact, actually has no mode. And that's where things, again, kind of become a little more complex or more unclear. It's the most frequent number. And since all of them happen twice, none happen more frequently than the others. If I added another 5, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 5, well, now the 5s occur more frequently than every other number, and therefore 5, the mode, would be 5. Okay. So if you need a little bit more information, I know Khan Academy has a really good, strong unit on the basic statistics. But this becomes really an important understanding as you're going through, and you'll hear the word central tendency. And the central tendency is this analysis of the mean, median, and mode. And we actually tend to stop using the word average to describe the typical. So average really just means typical, but different values can occur different ways. For example, if you're talking about the salaries at a company, you generally speaking have your lower level workers very low on the scale. And there's probably quite a few of them. And then you have sort of a medium level worker, like a manager or whatever. There's just not as many of them. And then normally you have the last person would be like a CEO. And they're way out here. And so if you were to calculate the mean of these sets of numbers, this CEO is going to really be able to individually balance out all of these people that have lower salaries. And so you might get a skewed value for what is the typical worker at that company based on mean. But if you're looking at median, if I'm looking at the middle set of numbers, your median's probably right in that region. And you'd see that the company doesn't pay maybe as well as the numbers indicate. They use this for housing markets. When you have like a $2 million home next to a bunch of like $500,000 homes, it's going to look like the surrounding area has a much higher home price than it really does, because you have that one $2 million home balancing out several $500,000 homes. Okay, so it's important that you understand the distinction between mean, median, and mode, and analyze those numbers as they're given to you in those problems. The last thing that I want to talk about real quickly, real briefly, is standard deviation. All right, and standard deviation is really a measure of spread. And what I mean by that is, if you look at the examples that I have, the 1, the 2, the 3, the 4, and the 5, we can tell you that the mean of this data set pretty quickly is 3. And the numbers are fairly tightly jumbled up. So this would have a low standard deviation. But if I were to look at a data set where we went like 3 in the middle again, 13 and 23, -7 and -17. Again, the mean is going to be 3, but it's going to have a higher standard deviation. And so that's what I mean by spread. It's the amount of distance between the numbers. You could even look at a set like 3, 3, 3, 3, and 3. This mean is 3, and the standard deviation is actually going to be 0, because there's no distance between those values. And so that's a frequent word that you're going to see in problems. It's important to understand how you get there. And so there's another word associated with standard deviation called variance. And it's each of these are based on the mean. So being able to calculate the mean is really important statistically for us. It also has some offshoot values. And so the way you figure out standard deviation is you're going to have a set of numbers, and what you do is you take the sum of the mean minus each entry. Square it. And now there's different standard deviations, whether it's population or sample deviation, but we're just going to give you the basic. You're going to divide by the number of numbers. and this is equal to the variance. Okay, the only difference between the variance and the standard deviation is I take the sum of all those means minus each entry, and take the square root of it, and this is your standard deviation. And so I'll do one really quick example for you. Your calculators will oftentimes be able to do this for you, but let's just look at the 1, 2, 3, 4, and 5 set. And so how I calculate this, again, we'll start with the variance. So it's the mean. We knew the mean was 3 already, so I'm going to take the sum of 3 minus 1 squared plus 3 minus 2 squared plus 3 minus 3 squared plus 3 minus 4 squared plus 3 minus 5 squared. I know that there are 5 numbers in my set, so I'm going to divide by 5. So this is 2 squared plus 1 squared plus 0 squared plus negative 1 quantity squared plus negative 2 quantity squared, all divided by 5. That's 4 plus 1 plus 0 plus 1 plus 4, all divided by 5, which equals 10. So 10 is my variance. 10 divided by 5, sorry, equals 2. So 2 is my variance. And then, if I want the standard deviation, I take the square root of 2, which is approximately 1.4. So this is the average spread of my numbers. Okay, and so this should sort of make sense because you have one value that's at the mean, but then one's 1 away and one's 2 away, so it's kind of like the average between those, that distance. If you were to calculate that with your other problem, your other set, so negative 17, negative 7, 3, 13, and 20. We can do that one quickly also. It'd be 3 minus negative 17, quantity squared, plus 3 minus negative 7, quantity squared, plus 3 minus 3 squared, plus 3 minus 13 squared, plus 3 minus 20 squared, all divided by the number of numbers, which is just 5 again. So this is 20 squared plus 10 squared plus 0 squared plus 10 squared, negative 10 quantity squared plus negative 20 quantity squared, all divided by 5, which is 400 plus 100 plus 0 plus 100 plus 400, all divided by 5. And that's 1,000 divided by 5, which is 200. So this is my variance. And if I want the standard deviation or the average spread, I square root this. So square root of 200 is 10 square root 2. So approximately 14.14. So approximately a spread of 14 points per. And so that value is important statistically for people to understand how well that data set is spread out. Now, where does this come into play? Well, it's really important when we get to this concept called normal distribution. And you might be wondering, what is normal distribution and how does it impact me? Well, things like the SAT and the ACT and a lot of other standardized exams that you take are considered to be normally distributed. And what that means is that there's a symmetry along the distribution of the scores. Dead center of that is the mean. And so again, the standard deviation is the spread out from that mean. And so where we can get really, really impressive mathematical results is like this. If I'm within one standard deviation plus and minus, I know that 68% of all the scores go within that. Okay, if I'm within 2 standard deviations, so again, you're subtracting off another one, you're adding another one over here. So between these two spots, this is 95% of the data points. Finally, if I'm 3 out, it's like 99.5% or 7% of the data points. So it's pretty much all of them. Okay, and they call this the empirical rule. And it just describes how these are spread out. And again, it really impacts you as you're going through, I think that's 99 points or 6. It really impacts you in your SAT and ACT. So that's just a basic. If you want to know more, you can definitely go on to Khan Academy. It's really important that you do understand mean, median, and mode. Much more specialized information would be an understanding of the standard deviation and the normal distribution. Thank you for your time.